In this video, we're going to actually go ahead and calculate the atomic mass. You've probably noticed that most atoms have an atomic mass that is not a whole number. Right? So if you're looking at all these numbers, right, these are your atomic masses, they're not whole numbers. That's because the atomic mass is the weighted average of all the isotopes. That means we have to consider the percentage of each isotope. For instance, for chlorine 35, we saw on the mass spec that it was 34.97 AMU and 75%. Chlorine 37 was 36.97 AMU and 24%. So if we look at it, the atomic mass of chlorine is going to be somewhere between 35 and 37, probably closer to 35 because we have more of the chlorine 35, right? So in order to do the atomic mass, we take the mass of the one isotope, okay, and multiply it by its percentage, right, over 100. And then we take the mass of the other isotope, multiply by its percentage over 100, and we add that up, we get 35.4594 AMU. Now, we really only have 4 sig figs to go with that, so let's round that off to 35.46 AMU, which is what you'll find on the periodic table. So let's look at rubidium 85 and rubidium 87. In this case, I know the mass, or the mass number. We can use the mass number instead of the mass. Okay, 85 AMU and 87 AMU. And what I want to do is see if I can figure out the percentage of each isotope without looking at a mass spec. Okay, I can look at the periodic table and see that the atomic mass is 85.468 AMU. So what do you think we have more of? Do you think we have more of the 85 or the 87? Well, since it's 85, we probably have more of the rubidium 85. We can do better than that even. We say 85, 86, 87. We're in here somewhere, and that's about 3/4 of the way, right? So there's probably going to be about 75% of this and 25% of this. Let's do the actual mass and see what happens. So, atomic mass, which we said was 85.468. Remember, that just comes from the periodic table, right there, equals the mass of the first isotope times its percentage plus the mass of the second isotope. If the first percentage is X, what's the second percentage? Well, there's only 2 of them, and they have to add up to 100, so this one's going to be 100 minus X. Okay. And of course, this is all over 100. So start by multiplying both sides by 100. 8546.8 85X plus 8700 minus 87X. We've got a minus 2X on this side and a minus 153.2 on this side, divided by minus 2. And we're going to get X is 76.6%. And this is the one we called X, so it's going to be a rubidium 85. And then just subtract from 100, and you've got 23.4% of the rubidium 87. So we can take the masses and percentages and find the atomic mass, or we can take the atomic mass and the mass and find the missing percentages. Really only works if you have 2 isotopes, though.